Okay, tough time to speak towards the end of the day. Everyone's had a long day of talks. I promise it's not going to be too boring. I'll try and get through it as much as possible. Try and, if you have questions about what I'm going to talk about, whack your hand up. Let's have a talk. Let's have a discussion, right? I'm trying to break the mold of where we're trying to go in the DevOps ecosystem at this moment in time, so it will be triggering. I can guarantee you some people will think, you're crazy. It is not going to happen. Okay, so this talk is called It's Time to Rebuild DevOps. Anybody who does not know the word DevOps? Exactly, okay? So this, DevOps is a thing, right? It has been going on for a long time. So my name's Paul Stack. I work for a company called System Initiative, which we'll think about a little later. I am a former Terraform engineer, a former Pulumi engineer, a very frustrated infrastructure user, and I'm now trying to change how infrastructure management happens in a new and positive way. I'm sure everyone's heard of tools like Terraform, Bicep, CDK, Pulumi, stuff like this. This is not new territory, okay? So let's think of a few things first. Imagine a world where product owners, development, QA, IT ops, and InfoSec work together. Not only to help each other, but also to ensure that the overall organization succeeds. Okay, wow, what a panacea. Okay, fuck. If only life was like that, right? If only our jobs were like that. Okay, by working toward a common goal, they enable the fast flow of planned work into production. Holy shit. Now, this is not new. Okay, this is what agile and continuous integration, continuous delivery, and the movement into DevOps try to facilitate. Okay, and this is a quote from the DevOps handbook, okay, Gene Kim from 2016. If you like DevOps and you love understanding flow and application and software delivery and infrastructure delivery, go and read this book. It is wonderful, okay? It will give you new ideas in order to do different things in a different way, okay? But what this is actually telling us, okay, is summed up in a single quote for me from a person called Chris Reed. Okay, Chris Reed is a former thought worker. Back in early 2000s, he actually tweeted out and said, unless your pretty code is in production, doing what it does and making money, you've just wasted your time. Okay, so everything in application software and infrastructure delivery boils down to that quote for me. It's about making money. Yes, you can work for a not-for-profit, I understand that. But our companies need to make money, okay? We're not here to do this for free, okay? We've seen many talks where OSS is changing considerably and things are being overtaken. We are in this for our living. DevOps is absolutely eating the world, okay? And it's got a very simple origin, okay? Super simple origin. It doesn't have a big backstory or anything like this, okay? So what actually happened is a man called Patrick Dubois, okay, who is a Belgian. Back in 2007, he was super frustrated because it was really difficult for ops teams and development teams to work together. So they were passing tickets back and forward, like Jira tickets or whatever system you used back then, okay? And in 2008, a person on the left called Andrew Clay Schaefer proposed a Birds of a Feather talk at an Agile conference in Toronto, and it's called Agile Infrastructure, okay? This piqued Patrick's interest. Patrick turned up to the Birds of a Feather talk. He was the only person who turned up to that talk. Andrew Clay Schaefer did not turn up to that talk. He made the proposal and didn't go, okay? So, back in 2008, thinking of Agile Infrastructure, it's off the charts. Okay, so they caught up a little bit and they started discussing some things, and they actually formed a user group called the Agile Systems Administrator Group, okay? Fast forward to June 2009, and a man called John Allspaw and another man called Paul Hammond actually gave probably one of the most synonymous talks of where this all began, okay, at the Velocity Conference in Santa Clara. Okay, it's called 10 Deploys a Day, Dev and Ops Cooperation at Flickr, okay? Now, 2009, 10 deploys a day. That was pretty much unheard of. In fact, in 2024, that's still quite unheard of for most companies. Okay, so they were so far ahead and it really ignited a lot of the things. Okay, now of course there was a lot of back and forward on Twitter, actual Twitter, not X, the actual artist formerly known as Twitter, and there was like a whole discussion around these different things. And Patrick was like, oh my God, I'm not there. You know, maybe we should hold one of these conferences. And a person called Paul Nazarat actually said, why don't you hold your own? Okay, so they did. And it was called DevOps Days. Dev from developers, ops from operators, coming together as DevOps Days. If anybody tells you that that's not where that came from, this is where it came from, okay? This is genuinely, it's about these people coming together and having a conversation and bringing other people together into the world, okay? And it has taken over the world, okay? So in 2019, there was 80 DevOps days, okay? Before the period that historians will know as the COVID era, there was 80 in that year, okay? Last year, when we got back to, I'm not going to say normal travel, but more normal travel, there was over 60. So far this year, there's already 60 planned, okay? And it's so close in so many different areas around you. There's one in London in September. There was one, it was just last September. It was a fabulous event, I'm told. So, you know, it's growing. But it's a phenomenon, right? And all it's there to do is to solve the communication around developers not throwing their shit. I'm going to probably swear. I'm living in Northern Ireland again. This is like day-to-day words for me. It's developers and operators not just throwing stuff back and forward across a wall and being separate, okay? It's not about them doing each other's work, because that is another misconception of DevOps. It's about them working together and collaborating, okay? So it's not that there's a wall there. This ops team is not this special team that you feed pizza under the stairs, okay? They do have feelings, and sometimes they're like normal people as well. I'm an ops person, and I'm sometimes normal, you know. So it's really a case of them working together. But what we've discovered is we know that there is a delivery pipeline. Okay, so what we have over here is we have an idea. We have a business case for it. We have a plan. Then we go into these iterative cycles. We build, we test, we deploy, we make money. Okay? We start it again, and we start it again, and we start it again. Okay? That's the general shape of software delivery. Now, each independent company and each independent team can have different slices inside, and things can happen differently, but it's the general shape of software delivery. The idea has to come from somewhere. The plan has to come from somewhere. People execute that idea. We make money. If we don't make money, what do? We go back and come up with another idea. Okay? If it makes money, we make it even better. We make it faster. We probably even do all other sorts of things that go with it. And if we achieve this, we did it, right? That's a success. We're going to be unicorns. We're all going to have Bugattis and boats and shit, I nearly said it again, things like that. But it's absolutely fake news, okay? Because while it's been an incredible success for some people, and I really have to caveat for some people here, it's been an unmitigated disaster for a lot of other people. Now, that is not because of their fault. It is not because of the tool's fault. It is because they have tried to take an existing idea that belonged to another company or another way of working and try to shoehorn it into their environment. Anyone ever heard of Etsy? Okay. In the ops world, if you're an infrastructure person or you are interested in infrastructure, you more than likely have heard of the infrastructure team at Etsy. Okay. They were unbelievable at what they did. They built an entire pipeline of tools around infrastructure delivery, okay? You speak to the infrastructure people around the time of DevOps days and stuff like that. The aspiration was to work at companies like Etsy because they were so good at what they did, okay? Now, you cannot take Etsy's model and put it in your organization. I cannot take Etsy's model and put it in my organization. Each person each company, we can't just do the same thing. It's not a carbon copy. Yes, the software delivery pipeline is essentially the same shape, but you can't just take other people's tools and processes and shoehorn it into your own. This is where most of the failure has happened around this. Okay? If we look back to what we're doing now in 2024, we are still trying to achieve what companies in 2009 were doing. Okay? That's 15 years we're playing catch up in some of these places. And at this point, some people are just using this as checkbox exercises. Yes, we're DevOps. Yes, we use infrastructure as code. We don't have a clue what it does, but we do it. Yes, we use OTel. I don't even know what OTel is, but yes, we do it. We have structured logs. We have observability. What does it mean to other people? Nobody knows within their organization. There's no ubiquitous term within company to company to company. And yes, there are people who are very, very passionate about it. And I'm not saying that we don't know across the ecosystem. Within each organization, if I asked 5 people, they wouldn't be able to give me the same definition for their org. Okay, so DevOps has been successful, but not for everyone. So for me, okay, hot take incoming, okay, because I'd like to spice things up a bit. You may disagree. I'm not that bothered. I do bother. I'm kidding. Okay, like there is a lot of thought going into these key problems for me. And the first one and the most important one for me is paper cuts. Now, when I say paper cuts, I mean to do our job today, we have to stitch together so many tools, it's unbelievable. Shocking amounts of tools, okay? There is like no standard in how these tools come together. During a working day, you have to open your dashboards in this tool, your dashboards in that tool, your infrastructure as code in this language, your whatever, like your Docker files, all of these things, right? And it's not getting easier. We're making it harder. We're adding more tools in to fix the crap that the other tools have created for us. And it's because we care, right? We're not doing it just for shits and giggles and for job security. Some people are doing it for shits and giggles and job security. I'm kidding. Nobody does that for job security. I've not met a single person who actually puts poor tools in, okay? But this is really a case of we are just papering over the cracks that are there rather than rethinking the existing system. Collaboration. Oh my God. Anybody not use GitHub or a Git-based tool like this? Okay. Anybody not like it? GitHub pull requests, this is a hot, spicy take, is the worst possible place for collaboration. It is genuinely the worst possible place for collaboration, okay? There are so many problems today with a pull request. So many, okay? One, whose job is it to look after and review pull requests? Like, do you have pull request people who look after it? No, you have to do it as part of your job. What takes precedence? Write your code, mentoring juniors, architecting the system, looking at pull requests. How do you look at a pull request? I mean, there's been a talk today about better pull requests, right? Better collaboration. Now, the issue is that when we go into specialist tools and specialist languages, we increase the barrier to entry for pull request collaboration, okay? And oh my God, have we seen some rubbish in pull requests? There's a typo there. Who cares? Who genuinely cares if there's a typo in a variable name? I mean, what harm is that going to do? We have autocomplete. We probably have some rules around it. It'll be picked up eventually. It doesn't really require us to restart your entire CI pipeline for the variable naming, okay? There's a nitpick. 2 spaces, not 4 spaces, for Christ's sake. Like, I mean, you know, there's more to life than worrying about the nits of a pull request. I truly believe that our quest to put everything in source control has made it harder to use our tools. Okay? A lot of these tools today are not designed for what we put in them. Okay? Anybody use Terraform? Anybody accidentally stored a state file in GitHub? That is not supposed to be in GitHub, is one. Two, even though it looks like JSON, it is not JSON. It is a binary document, a binary file that you can't really diff very easily. Okay? We've made it tough for ourselves. Okay? And number three, again about source control, the source of truth. I'm going to pick on somebody. Who wants to be a volunteer for me? I need one, just one. Okay, Kendall.
All right.
You have infrastructure in the world today. Okay? You have that infrastructure in your source control. Where is your source of truth?
The actual deployed instance.
Yes, that's the first time somebody's given me the right answer, like this last couple of months. Okay, that's the trouble. Okay, the trouble is that we believe that our source control is the source of truth, but it's not. The source of truth is actually the infrastructure running in the real world, because there are other factors that change that deployment, that instance, that stuff, okay? And I mean, if your source of truth is your source control, and you have a production outage, and you have to change something in your source control that can take 2 hours to change an EC2 security group rule to go through, I mean, as a CTO, would you rather they went to the AWS console and changed it and then backfilled it in the AWS or in the source control? Or would you rather they followed the guidelines and pushed it out through? I mean, if my business was down, I would rather they went to the console and then fixed it later. Okay, and maybe some people may disagree, but I'm trying to think more business-minded these days, not like silver lining. So we've made these three key problems for ourselves, okay? Now, when it comes to collaboration, this is a true pull request. This is a genuine pull, a true pull request, okay, where somebody has changed some Terraform code, Azure Terraform code, and a tool that they have put into place has created 1,170 comments, okay? Now, try and find me a problem in that pull request comment. Collaboration failure. No, maybe it's not a failure. Maybe that's okay. Like, I mean, maybe you can filter out all that rubbish. Maybe AI will be better for us to do that. I don't know. Source of truth, failure. Terraform plan or destroy fails when an AWS is referenced by another resource but was deleted in AWS. Anyone ever hit that problem? Terraform plan, Pulumi preview, looks great, ship it. When you apply it, oh my God, this resource doesn't exist. What happens? Okay? I mean, the plan and the preview told me it was okay, so it should be okay, right? But your infrastructure is not, the source of truth is not in the repo, the infrastructure is the source of truth. Another one, and I can't just pick on Terraform. I'm not picking on any specific tool. It's really not. I've written a lot of both of them, so I'm pointing out the problems of both tools. Like, all tools are the same, okay? Destroy fails when an AWS resource can be found. Do you want to perform this destroy? Yes. Boom, apply failed. We've made it hard for ourselves. There's an opportunity. Where there's an opportunity, there's money to be made, and this is what we've done. Look, plan and code tools, build, test, and integrate tools, operate and monitor tools, release and deploy tools. How do we start? Where do we start? Which tools do we pick to start? I need one more volunteer. Tell me how there is no wrong or right answer to this question, okay? This is purely subjective. Each person, each team, each company will use different tools, okay? I am purely interested to see where people will start. Tell me how you would take a simple web application and deploy it today to the cloud. What tools would you use? Where would you start?
Azure pipelines.
Azure pipelines, okay. And what else with it? Anything else with it? Azure pipelines give you everything you need? Yeah? Give you load balancers? Does it give you like certificate management?
Yeah, no.
You see what you're not wrong. You're absolutely not wrong. What you're saying is 100% correct. I ask this question as an interview question, okay, when I'm interviewing infrastructure engineers. And actually, we've changed it into an interview technical assessment now. Here is 2 simple web applications, a back-end server and a front-end server. Deploy them. Use any tool you want, deploy them. I've seen Vercel. I've seen Netlify. I've seen Kubernetes. I've seen Azure, what's it called? Azure App Service. I have seen like 60 different ways of doing it. And I'm still impressed with different ways that people actually do it. And it's like, and part of the interview question is, how did you choose what you chose? Tell me what led you down that choice that you've actually gone. And like some people are like, well, it's a Node.js application. I can just put it in Netlify and Netlify will build it on the fly. Great. Don't need to worry about CI pipelines. Netlify will build it for me. It has a UI. It has a simple trigger from GitHub. Great. Brilliant. Other people are going for Kubernetes. I'm like, do you hate yourself? Sorry, I'm kidding. I do rib on Kubernetes a little bit. But in actual seriousness, and they're like, oh, it gives me the ability to scale out when I actually need it. It gives me the ability to isolate the public and private traffic. It gives me the ability that I can put ingress controllers on the front of it, and I can integrate it with a database or secrets. Great. Can't fault you for doing that. You're thinking of scalability. You know what I mean? So we've made it very difficult to get started in this ecosystem. We really have. But what if I want to change that piece right there? And you've seen this meme in hundreds of different contexts, but it's the same thing. And usually it is, though we don't touch that one. That one's risky. That one's a little risky because the way we have structured our infrastructure as code means that if we change that, we'll have a trigger on everything else to rebuild. That's interesting, isn't it? What happens if that sort of scenario goes, you go, well, we'll just leave this on the oldest possible version and hope that it doesn't happen, or I'll leave the company and somebody else can pick it up, because that sometimes happens as well. I'm not gonna lie to you, okay? And this is what I mean by paper cuts. It's death by 1,000 paper cuts. Every day we face a challenge that we shouldn't face because we've papered over cracks that exist today. I haven't even talked about security, okay? Because those poor people are just in a complete island of their own, and they're even more frustrated than DevOps people, okay? I feel so bad for DevSecOps people because they're just excluded from all conversations. Look, we still have, I'm up here talking about devs and ops working together, and I just ignored those people. Didn't mean to ignore them. It's just, that's what happens. We got things wrong. Now, when I say we got things wrong, DevOps should favor people over process and over tools. But what we've actually done is we've gone the opposite way. And we've taken tools over process over people. It has led to a number of problems within our system. Firstly and foremost, the elephant in the room, it has led to burnout. Okay? It is shockingly bad, the pressure that some people have to work under in order to keep their systems up and running because they haven't had the chance to influence the tools and the process to get there, okay? If any of your CTOs or high-level people within the leadership org, if you've gone in and told, this is the way you will be doing it, you're part of causing that strain and stress for them, okay? Now, I actually kind of feel that the 3 pieces are synonymous with each other, okay? Our culture, our people, our tools all have to coexist together and be symbiotic to achieve what we want to achieve, okay? You can't have people enjoying the culture if they have to use shitty tools. You can't have people successful if they have to use poor process. okay? You can't be successful as an org if you have a poor process. So they all have to work very, very, very closely together. In fact, the tools kind of dictate the culture that we're started to be in. Okay? And it even scares some people from applying for roles at organizations because of the tooling that they use. So it's become part of what they are, the DNA of the team, of the organization. So it's difficult. But kind of what's happened here is we have an evolution of tools in this space. This is not all of the tools, okay? This is the major players, so to speak, okay? So CF Engine, okay? This is 2008. We have, not 2008, 1998, I take that back, I'm sorry, 2008. Okay, so way back, this was the parent of all of the config management infrastructure as code tools. It is written by one of the most smart people I've ever had the privilege to speak to, Mark Burgess, who still writes, Dr. Mark Burgess, I take that back, I apologize, who still writes incredible books and theory around promise theory and about these different areas, okay? Now that scaled off in 2005. Luke Knies wrote Puppet. 2009, Adam Jacob wrote Chef. Okay, 2011, SaltStack was created. Okay, 2011, CloudFormation actually came out in 2011, believe it or not. Okay, Ansible then came 2012. Terraform, even though it's felt like it's been around forever, it was only 2014. Okay, not that long ago, reasonably. Okay, ARM templates came around at the start of Azure in one form or another. They were available from 2014 when Azure came out. Google Deployment Manager, anyone ever used Google Deployment Manager? I don't even think Google use it. I think they use, I'm kidding. Again, it's just another tool, right? It doesn't matter. But yeah, 2014 as well. Pulumi came around in 2018. Later in 2018, CDK came around. There's a funny story there over beer, just saying. 2020, TF CDK sort of became a thing. It's still not GA, but it's around and people do use it. Okay, so that's the ability to create your Terraform in a CDK-style construct. And 2020, the world's bicep was created. Kidding. I actually don't mind bicep. I just think it's another superset of a DSL. Okay, but have we learned anything across these tools? Okay, first one, DSL. Second one, DSL. Third one, Ruby. Fourth one, DSL. Fifth one, JSON. Sixth one, YAML. Then we have Terraform in a DSL. Deployment Manager, YAML or TOML. I don't know what construct that uses anymore. ARM templates. Pulumi, different language. I think Pulumi's up to 8 languages now. Okay, TF-CDK has a couple of different languages. Bicep, we're back in 2020 to DSLs. We're not learning. Okay, we still throw this same argument out there. Declarative, imperative. Who cares? Genuinely, who gives a shit? Okay, it's 2024. It's time to start thinking about a new paradigm. It's time to start reinvesting, rethinking about what we're trying to do. And I'm going to hook you in a little bit, don't worry. Okay, so what's next? Where do we go? Okay, if we find the next big thing, we're going to be Scrooge McDuck rich. Okay, because there is a big evolution in the ecosystem, and there are a lot of tools starting to appear. You have tools like Winglang, Dagger, Pulumi AI, Clotho, Shuttle RS, Garden. You have 100 new companies doing things in 100 different ways. Okay, whether it's annotations, whether it's universal code that can be used for CI across environments, it's huge. Maybe platform engineering have figured it out. What's platform engineering? It's the ability to deploy an internal system so that developers don't need to care about it. Okay? That sounds great. Hot take. In my personal opinion, I think it could have created more silos. I don't think enough people have actually had great exposure to the platform engineering team. And what they do is they just send a ticket saying, hey, platform engineering team, can you add this ability? Now, tools like Backstage, etc., give people the ability they can extend it better. So it will get way more flexible and more useful over time. But I don't think in 2024, the people who are going, platform engineering is the future because these 5 companies have done it, we're going to put a platform in place, are setting them up for the right success here. Okay, again, if it's worked in some places, it's not going to work in everywhere. That's not how it works in the IT. There is an author called Rick Rubin. Okay, he writes a book called Creative. It'll come back to me. Sorry. Okay, but the one quote that sticks with me in this is, "Rules direct us to average behavior. If we're aiming to create works that are exceptional, most rules don't apply. Average is nothing to aspire to." That is a phenomenal quote. Okay, don't aim in 2024 for what we were trying to do in 2009. Okay, we're a little past that. We should be thinking outside the box. We should be thinking differently. So this is why the hook time. You ready for fishing? This is why we're creating System Initiative. Okay, so System Initiative is a real-time multiplayer, multimodal reinvention of DevOps tooling. Oh my God, what a mouthful. Okay, now it can be broken down into a load of different things. System Initiative is a place where you can do whatever you need to do with your infrastructure. And I'll show you what I mean by that. But the one thing that makes System Initiative different than everything else is we use digital twins. Anybody not know what a digital twin is? I will give you an idea, okay? Firstly, I'll put it into Formula One racing, okay? Because that's the idea that most people know. You can't just change something in a Formula One car and put it on the track. People will die, okay? In its simplest possible terms, that is what the case is, okay? Now, if somebody breaks something in your infrastructure, more than likely, people will not die, okay? We just put that out there. Now, there is chances that maybe, but if you work in that type of company, then you have other things that you'll be worrying about than worrying about a digital twin. But the way it works is you kind of have 3 pieces to a digital twin. You have the real world entity. Now, I realized when I put these slides together, after what happened with the Boeing planes and stuff, probably using a plane wasn't the best thing to use as a digital twin, but go with me and just forget, right? So you have a real world entity, and you have a virtual representation of that entity, and you have data that connects them. Okay, now that's the important part, the data that connects them. Now, the tools today don't have the separation between the real world and the virtual representation. If you change something and you apply, you are changing the real world. Okay, not that they're wrong. When all of these tools were created, this is the bet that the tools were taken, right? We're kind of looking at it a little differently. We're like, why don't we test all of our changes to infrastructure in a simulation, and then we are in control of when something is released to the real world? Okay, now that's an interesting concept because we are in control of when we actually deploy. And there is a complete separation of merging to main and deploying the infrastructure, okay? Because that's what happens in Terraform and Pulumi and stuff today. When you merge to main, a pipeline usually kicks off and it deploys it, okay? But what then happens is we go, ooh, it's risky. It's risky to merge it. And then, lo and behold, you want to merge on a Friday afternoon, right? So we end up then batching the changes into bigger amounts, and that increases the risk, rather than what we're aiming for of a continual cycle of release of systems into production. So a digital twin allows us to do it in a slightly different manner. So we have an EC2 instance, a component. We have an EC2 instance, which is a real world thing, and we have actions that make them happen. Virtual representation, real world representation, data, okay? Now, you could technically describe it as an actor model where Your EC2 instance is a thing, and the actions are the behavior that appears on the thing, and the thing can like mutate itself and change itself, but that's way too complicated for me. So I like digital twin. Now, in order to do that, we need to create what's called a hypergraph of functions. I love that term. I just love, like that's the type of term that you would use in a VC pitch deck, and they'd be like, that sounds fucking brilliant. Right? But it doesn't really mean a huge amount. A hypergraph of functions, what it means is that there are functions connected to each other. Okay, and I'll show you what that means, okay? So we have a Docker image, and I'll show you it on the screen, and I'll show you it working, and that Docker image has an output socket, and that output socket has a function, and that output socket feeds into an input socket here on the Kubernetes deployment, and that is a function, and if you change this, this function runs, this function runs, and this function runs, okay? So at any point, we can compute the changes that are going to happen as part of our pipeline. And we get a full list of the changes. Let's look at it. Now, I'm running this locally, okay? So it may not work. So like this is system initiative, a UI. You will see that there is some drag and drop elements. It is not a clicky drag and drop tool, and I will show you the reason why. Okay, so let me firstly spin up my local stack instance, because local stack is amazing. And you'll see I have local stack running right here. And I will go back to Firefox, and I will create an AWS credential. And look, immediately, System Initiative has opened a change set. It has opened a simulation. There is nothing in the real world, so I can click back to head, and I can see that nothing has been harmed in the making of head, okay? But in my simulation, I can do it. And what I can do is I can then say, actually, I will show you that we are trying to be better about secrets, and we're not just pushing secrets around in plain text, because people are like, how do you manage secrets? Okay, so we have secrets, and I'm going to call this local stack, and it's a test access key, and it's HTTP 00004566, and the secret access key is very secret. It's called test. And we can actually see that the secret that it's created, like it is encrypted with a sealed box algorithm before it even leaves the browser, okay? And then it goes to the database and it is encrypted again. So we're trying to be good about secrets management, not important. But you did see that a function ran there. Did you see the box went spinny, spinny, spinny? Okay, that was a function that was running, and that was a qualification. And that qualification is a live check on the system as I am moving it around, and that check ran the function AWS STS get caller identity, and that checked that the credentials were active. Okay, now how did that function run? You can quick click into the customize screen, and you can search for credential, and you can go in here, and you can have a look at the qualification that it ran. This is the most sophisticated TypeScript that you will ever see in your life, but what it does is it makes an exec to the AWS CLI. It actually passes in the credentials that you use in order to check that it works, and it will return. Now, let's do this, and let's say success, credentials are valid. I will say hello, NDC London, to show it is a full fidelity system. You do not have to wait for binaries to change or for providers to change. You have full access to what you're doing. You can go back to the model screen. We can click on this. We can click on the qualifications, and we see hello, NDC London. So it is fully live. It doesn't require any external plugins or systems. You can make it talk to whatever CLI, whatever API, anything you want. It doesn't really matter. Internally in the system, we spin up a shit ton of Firecracker VMs, and each function is executed inside a Firecracker VM so that they are totally isolated from each other. There is security the whole way down through the stack, and at the end of the Firecracker execution, we destroy the jail and a new one is replacing it. Okay? Internals of the system, not really super important, but at that point, we can start to model new stuff. Okay, so we know that most things inside AWS need a region. You can substitute in a resource group. In Azure, it would be the same, right? You put things inside a resource group, and a resource group has a location, but we'll drag a region onto the screen, and you will see that it's going to, right now, it's going to run a qualification. It says there's no region name, but let's change it. Let me make it somewhere I don't have access to. GovCloud, I definitely don't have access to GovCloud in this ecosystem, this environment. And it says it's available to use. Strange, local stack is telling me I have access to, strange. Let's try a different one I know I don't have access to, which is Israel, because you have to opt in AWS to do that. And we will get a failure here, which is region is not opted into use, okay? So it is a live lookup of what is going on in the system. Okay, let's add some things in here. So let's create a Docker image. Let's create a butane configuration. Butane is like a way of hosting a Docker image. It creates a systemd unit file inside CoreOS. And what we can do is we can say that the system init /whiskers, which is a publicly accessible Docker image. You'll see it's propagating a function right here. You see it's running the functions. It's understanding the scope of the update. It's passed the function name in. It's run a qualification in the background to say that Docker image does indeed exist because it's able to check using credentials or whatever you need. And then lastly, we are going to, I don't know if you can see. Actually, let me zoom in a little here because this is cool. Okay, so you click on Docker image, and I don't know if you see the other socket on the input, it gets bigger. It's telling you the available places on the screen you can make that connection, okay? So we can connect it here, and what's going to happen is another function runs here, and it actually spits us out a systemd unit file. Okay, so it's pretty useful to do. Now, I told you it was a hypergraph of functions. What that actually means is if I change the top level, then the Docker image is going to change. That's then going to pass out, the function is going to come out through the container image. It's going to pass it into butane, and butane is going to generate a different systemd unit file. The systemd unit file will be for Nginx. So we're passing data along, and it's aggregating it, and it's rerunning the functions as it needs. Now, not interesting because it doesn't have a resource in the real world. But if I do something like a key pair, actually, let's create a couple of them. And let's copy these. And let's copy two more, because I can copy and paste my infrastructure, which is, again, that's a baller move. And you can start to see, like in the diagram outline, all of the different pieces of your infrastructure. You'll see if it actually passes or fails. But we know that each of the key pairs can't actually work because we can't deploy into that environment. So let us change to US East 2. Let's watch that qualification run on the top level. And then lastly, what will actually happen is each of the individual key pairs themselves, because the function at the top has been changed, they will run, and they will also now be in US East 2. Okay, great. Doesn't really mean anything. What we're actually going to do is we're going to say, but I want these to go out into the real world. We can see in our simulation, we can see all of the different pieces that it's actually like made. And lastly, it's going to tell us, I know I need to create 1, 2, 3, 4, 5, 6 key pairs. I can click Apply Changes, and it will actually throw the champagne. It's cool. It's real. And different ones happen at different times. It's what it's actually going to do right now is it's merging the change set back to head, and it's actually syncing these changes out into the real world. And what that actually means is we should see some API requests happening here in a second, maybe, if I haven't messed it up. Oh, they're already done. There we go. So, like, we have our key pairs. I'm not quite sure why. Oh, there we go. Yeah, the creates happened. Look, create key pair 200. This is local, of course. This isn't talking to AWS to make it fast. So at that point, we actually have infrastructure that we maintain and manage. Now, I said that there is a difference between a model and the real world. This is currently what's the state in the real world. Let's open a new change set. Let's delete this one. Let's delete this one. So we know that we're going to have two actions that delete it. We know the cascading effects that would actually have, but we know that it's a simulation, and I can at any point go back to the real world and go, don't worry about that work. That was a test. That doesn't happen. Let's ignore that we're going to break our entire system. Now, where are you? Wouldn't it be great if multiple people could use that system at the same time? That would be cool, wouldn't it? Okay, so I am now logged in as a different user. I have a user in Chrome at the bottom, and I have a user in Firefox. Oh, look. You can see where we all are. We're very Miro-esque. We can actually do different things. But the cool thing about this is, let's create a change set. Let's go into the same change set. Let's change the function editor. Let's go to DB proxy. Let's also change the function editor, and let's go to DB proxy. And you can actually see what code I'm highlighting at the same time. So it is real collaboration where we would not just be pair programming via Zoom and one person is typing and the other person is watching it. You are actually working together. We held a session on Friday night, late, to deploy System Initiative production setup using System Initiative. We had 3 ops people all sharing screen on Discord at the same time, working in the same change set, and it was the coolest experience ever. It ended up creating infrastructure that is this complex. Okay, now, don't worry about the edges right now. We're tidying that stuff up. We're creating the ability you can abstract and stuff like that. Like, you can create these frames to segment parts of the graph where these 7 resources are your tail scale makeup, and this entire set of code is your database and your cloud front and your Route 53 record that's associated with it. So it starts to give you this ability to be able to change things in a different way. Now, back to not being boring, because sometimes people get bored with code. But what that actually means for us is really? My presenter view has disappeared. There we go. Thank you, Google Slides. So this ability to collaborate, this ability to be able to be reactive to see what's happening, this ability to actually understand the real world implications, I think is starting to move us away from the paper cuts of DevOps. Everything I've shown you is free. It is not a paid-for product. You can download the software. You can use it. You cannot use it. I don't mind. It doesn't affect my salary. I love working on the cool tool. Okay. Now, the interesting thing is that we are not trying to say we are the next big thing in the ecosystem. That is not the point of the talk. The point of the talk is that the ecosystem needs to change, and that there are already people trying to change that ecosystem to make things a little better, to be able to give you that ability to think outside the box and break those rules. Remember, DevOps was designed to focus on delivery. Okay? Not about the cool tools, not about the 500 tools that you want, not about writing a kick-ass resume. Okay? Yes, those are outcomes of the things that we do, but it is designed to focus on delivery for your users. That is going back to what the Agile Manifesto told us all those years ago, that we needed to care about our customers. Those customers can be internal or external, okay? This is why platform engineering is actually having such a huge benefit at this moment in time. They are creating tooling for internal users, internal customers of their company, okay? The second wave of DevOps, we think, is trying to facilitate collaboration. It's trying to understand real-time implications of changes, but it's trying to be infinitely extensible. Okay, tools like Winglang, tools like Clotho, tools like shuttle.rs, where you have like attribute-based infrastructure, where you don't need to think about the infrastructure, and it gives you the ability to write attributes above your classes and your functions, which will create the infrastructure in advance, are trying to move us to better practices. Just again, to think back to what Chris said, okay, a long time ago on the artist formerly known as Twitter. Until your pretty code is in production making money, you've just wasted your time. Everything we do should be to make our pipelines faster, not more complex. Tools that we put in place should make our lives easier to make that delivery faster, not more complex. DevOps is not dead in any way, shape, or form. Our aspirations were very, very correct. What we've tried to set out to achieve, what a lot of people are achieving, is working, just not for everyone. We just need to iterate a little more. Very important. So we can now kind of rephrase the DevOps cookbook, and we can actually say, imagine a world where product owners, development, QA ops, and InfoSec work together, not only to help each other, but to ensure that the overall organization succeeds. By working toward a common goal, they enable the fast flow of any work into production. Tens, hundreds, even thousands of changes, doesn't have to be just code, per day, while achieving world-class stability, reliability, availability, and security. Let's not always just think that code and complexity is the way forward and the answer. We can always look to different ways of working. If we want that world, we have to challenge our beliefs that exist today. Definitely in 2025, if we're still trying to fit pipelines that were in 2009, we're going to get slower. I'm sorry to say, folks. Break rules, think differently, act differently. Thank you so much. Enjoy the rest of the conference. And I have a few minutes if anybody has any questions. Don't all put your hands up at once. Yes?
So that graphical interface you showed, and it, you showed me there's quite messy. What do you think will happen when you have like a really big company and there's like more than 3 people working on this together? Do you not think it's going to get too...
Wonderful, wonderful question. So the question is like, how do we expect that graph to scale? How do we expect it to be useful? How do we expect it to like actually be a thing? Okay, so our graph is not finished. We're not even in production. Like we don't have a customer, we're not in production, nothing. What we're trying to do is we're making small turns of the product every day as we're using it ourselves. Okay, now there's a presenter who, in the architecture and software world, Simon Brown. Okay, Simon Brown talks about the C4 model. Okay, C4 model is about the diagramming and how you can zoom in and out depending on context. We can do a similar thing with this type of scenario, right? So you can collapse frames. You can see all those edges. I hate them. I absolutely hate them, right? Frames are going to take those away because those edges then become internal in the frames. Okay, so we can clean that up, right? The aesthetics of the graph is so easy to clean at this moment in time. What we're trying to focus on is we're trying to focus on the modeling journey, because that's how we as humans think, right? We think visually, okay? We don't immediately go and write code, because if we do that, we develop probably the worst code possible, right? We do draw some boxes on some whiteboards every so often, and we don't go back and ever update those diagrams on boards, but at the same time, there is an initial thought process that takes us in a location, okay? And what we usually do in infrastructure today is we take those diagrams and then we go and write Terraform or Pulumi code, and then we hope that the next person who comes into the organization can then mentally map that code back to the diagram in their head, right? Now, even if you didn't use system initiative, okay, making that collaborative effect of diagrams more useful within your organization would allow you to work much faster, right? It just so happens that for us, we're like, Well, people diagram, wouldn't it be great if it was doing real-time checks against the actual source of truth in the cloud? Wouldn't it be great if those actual boxes and edges became the equivalent of like resources in the real world? And we're experimenting to make that happen. Now, it is iterating every day, literally every day. Okay, we have a small company, the company's like 16 people, right? So 13 of those are in the engineering team, and we are making such fast progress. It's super fun to do. Right? I really mean it is one of the most fun tools to work at because we're looking at solving something in a different way. Now, even though the graph looks like that today, there is a sub-team that is completely rewriting the engine because when we started doing this, it was like, it's all in Postgres and it's using stored procedures. And we got that graph up to like 2,000 nodes. And then it started to slow down because of the data in Postgres, we needed to add extra indexes in the queries. So the other team is like, why don't we change it all to be graphs, actual graphs, and then we can make it immutable and put it in a content addressable storage. And any change is just a rewrite of the graph that gets added to the content addressable storage. It means you can undo, it means you can redo, you can replay events, all sorts of things, right? So we're not saying that this is the finished article. What we're trying to do is trying to create this ecosystem where people go, oh, so, we can like model stuff out. We have the ability for discovery, okay? The age-old thing that everybody who wants Terraform and Pulumi and all of these tools, they're great if you're building a greenfield system. What happens if I already have an AWS system or an Azure system? How can I bring that in? Well, what you have to do is you have to find all those little IDs and you have to use the import commands on those IDs. Ours is just running functions. What if one of our functions was discovery and the discovery was saying, because it's a digital twin, we found real-world resources. They don't exist in your model. Would you like to bring them in? Fuck yeah, I would. Bring them in. Like, the more in that you want, the better. Let's write some like diagrams. Let's draw some edges. Let's model some stuff. So we're very much getting to the point where we're dog-footing it ourselves. Okay, we will not put anybody on this platform without it going to a serious amount of nodes and a serious amount of functions. One, that would be irresponsible. Secondly, their experience would not be what we would want our experience to be, right? The guy who wrote Chef, Adam Jacob, the guy who wrote this, okay? He's frustrated with how the ecosystem has gone throughout the years. I've been involved with this now for a while. We just hired the guy who was like a Docker employee number 4 before it even became Docker, okay? We've got some people in here who care about changing the ecosystem, not just making the next evolution of the tool. We've walked back the tree and we've gone in a completely different direction. You don't store this in GitHub. You absolutely do not store this in GitHub. There is no way to export it to Terraform. There's definitely no way to export it to JSON. You don't have to send like packages to GitHub and download packages and stuff like that. We're actually building, rebasing, and change sets even into our code. So we're putting in vector clocks and Merkle trees so we understand the order of operations even within the functions themselves. Think of Git rebase on your code, and you're going to be able to do that on your infrastructure. So we're trying to get there. We're not there yet, and we're experimenting with different graph sizes. When we get to the point where the graph is so big, there's like Figma, Miro, those tools where they're collaborative. They don't load everything up front. They load the panes that they need. We're going to move to that direction as well. So a lot of the UI is WebSockets based. Everything's happening here on the browser, and then it's just talking back to your API server. So we're not quite there yet, but we're in the right way. We're building something that feels like, for an infrastructure person like myself, I would love to use it because I don't want to typey. It's like, I'm getting old. I want to retire. I don't want to be writing code for the rest of my life. So I want to kick back on my boat. I don't have a boat, but if I had a boat, I want to kick back on my boat. Oh, not yet. So this is where we're trying to get to, if that makes sense. Question?
I was going to ask, I often think about things in terms of like APIs rather than infrastructure, or like functions, and then they need to talk to each other. So when I think of that kind of graph, I think, well, I really just want to have an API and API and draw a line between them and describe what their amount of what that's allowed to do. So at an infrastructure level, I understand wanting to have like that great big, we've got that like automated approach. So you describe what
Wonderful question, okay? Like, doesn't care about like the internal implementation details, just wants to be able to like layers of abstraction, almost talking to layers of abstraction. Here's what we're planning, okay? I'm gonna give you a sneak peek. Select on the diagram, right click, extract as template. It is literally on our roadmap. We want to fix that engine first, and that's exactly what we want. We want people to be able to drag a component that is, give me a VPC that has 3 subnets, public, private, whatever. Give me a serverless application stack, and then you just point your code base at it and it does the best practices. It's exactly where we're getting to. Now, really important to note here, this is not just for infrastructure. I genuinely don't care. If it has an API or a CLI or can do anything, you can model it in this. Okay, it doesn't, as long as it's a thing that you want to model and actually like be able to pass data through and like be able to talk to each other, you can do it. So you could model 100 Docker containers or your CI pipeline in the same way, and it would just run your CI tools under the hood, right? You're still visualizing your pipeline. It doesn't matter. It's just an engine that allows you to be able to abstract and then add behavior as you need to go, rather than what we've done today, where we've gone, I need 3 resources in AWS, and the tool is like, I know exactly how to do that, so you have no control over how you're going to do that. We're going to do that for you. We're like, no, you have control of what you can do. So think of the scenario where you're deploying a migration of your database, and system initiative would like knows it changes this, it changes this, it changes this. It creates that layer of actions. You can click on your database first and add a workflow action that says, create me a database backup just in case anything goes wrong. And that would slot into the workflow, and that would actually happen because it's just behavior about, it's a behavioral based pipeline. It doesn't matter what comes out the other end, it's just acts the way you want it to act.
So please forgive me for a stupid question. I come from a front-end perspective.
Yeah.
There's so much shift left. You get more and more involvement in DevOps these days. Why I'm here. It's really cool. I wonder, is there any way to expose the cost implications?
Great question. Like, can you expose the cost implications? 100%, right? Can you let me share the screen again? You see this function right here? Come on. Right, so these are the functions that you can do anything you want in, right? So for example, this is the create, okay? The create is just doing almost the same as like qualifications and stuff like that, doesn't really matter. But at the end of this, you can go like exec my cost control tool and give me a response and throw that out as part of the response. We actually did have it in there where you would get a number at the bottom where it would tell you, but it wasn't accurate just because not everywhere exposes that cost level data. So we're trying to make it that is very much a extension point for the people who need to use it. And then even like, for example, if you're creating infrastructure, there are some organizations that are like, for compliance reasons, we have to create a Jira ticket or we have to create like a GitHub issue or something. Shell it, make an API request, create that ticket as part of the request, right? So it's fully extendable because it's not a black box. You have full access to every single function. In fact, you can add any extra behavior that you want, and you can just say, add a new function type, like a qualification. You can give it a name. You can attach it, and you can make that qualification do whatever you want. Like, it doesn't matter. So that's yes is the answer. We're just, again, we're trying to get the internals right before we put these sort of cool features in to like allow people to do extra stuff. Okay.
2 questions actually.
Good.
Where does this code live?
Oh, thank you. You're like an amazing github.com/
No, I mean the code that
Oh,
is evolving. So
it's a binary. So right now I'm just running some binaries, and there's, as part of like, I use tilt. Tilt is like the equivalent of running Docker Compose. Okay, so it brings up all of my services in the right order. There's a database running locally, so it's storing all that code in the database.
okay, so this
Yep.
is a TypeScript that you
Yep.
modify and it goes into
Yeah. We store that as we base 64 just to compress the data, and it's stored in the database. So it means it's versioned. Like we understand we can replay, undo versions of the code gen and stuff like that.
Just transparent.
It's just transpiling. That's all it is. Yeah.
Okay, cool. Second question, rollbacks.
Rollbacks of infrastructure. So what we're actually planning to do is, for example, this is the full, I need to go into production. This is the full list of applied changes. Okay, and you can see some of them are successful, some of them are not. What we're planning to do is add a little button here that basically says re-roll back to this point, because we know exactly the exact versions of infrastructure, for example, great example. So if I have a look here, oh, Jesus Christ. So we know the code that it's going to run. That's why. This Wi-Fi network, for some reason, it doesn't support my root certificate from ACM, which is Azure or AWS. So I can go back to the component, and I can see exactly what the code is at any time. So this is the code that it's going to push to AWS. This is the generated code, all of the generated assets. So you can roll back exactly to that code at any point. So you would undo to a certain part in the graph, because it's just a graph of functions, and the graph would relate to a certain time. So if this then changed, you would then have the ability to create or update or whatever the terminology would be for that record, and it would create you a new simulation, because you don't want to do it live, and it would then give you the ability to add that in. So that's exactly how we would do it. So yeah. Okay, thanks everyone. Enjoy the rest of your evening.